All right, so right here, we are going to talk about the difference of squares trick, okay? So to know if you can take the difference of squares, first thing we're gonna do is check, do we have a GCF? If we look at this first one right here with the 16x squared and the -1, we do not have a GCF there. They both don't have an x. This first one does, but the second one doesn't. And we don't have a situation where we have a number that we can pull out. So we don't have to worry about a GCF there, okay? So that's the first thing that you're always going to do. Always check for a GCF before all else. See if you can pull one of those out. We can't here. So since we can't pull out a GCF, we're going to check to see, hey, can I do difference of squares? Because I noticed that I've got a difference here in the middle. And if I've got two perfect squares, that means I can do the difference of squares and save me quite a few steps. Now, if we take our first term, 16x squared, and if we take the square root of that, that's going to give us 16x, okay? Actually, that's wrong. It's actually going to give us 4x, my bad. That's going to give us 4x when we take the square root. The 4, because the square root of 16 is obviously 4, but x squared and the square root, those like cancel each other out, and then you're left with just a regular x at the end, okay? Now, if we take the square root of 1, that's going to give us 1. So right here, we have a difference of two squares. We could rewrite this as 4x squared minus 1 squared, okay? And if we do that, that's going to indicate to us, hey, I have a difference of squares here, which means I can just go on and skip a few steps. And I've got 4x plus 1 times 4x minus 1, okay? We're bleeding over into the other problem a little bit. I apologize for that, okay? So that works, okay? We don't have to worry about the box method or anything because we have already figured it out using our trick, the difference of squares. Now for this one, we're going to do the same thing. Let's look to see if we've got a greatest common factor. Looking at both of these, I think both of these are divisible by, I think that the greatest common factor they have in common is 4. I'll try that out, and then if I notice that there's another greatest common factor, then we can always change it. We can always fix it. Okay, so let's start by trying to factor out a 4, because they both look like they have a 4 in common. When we do that, our first term is going to go down to 4n squared on the inside. And then our -36, that's going to turn into a -9 when we divide that by 4. Okay. Now, it looks like it's the simplest we can possibly get it. So let's see if it's a difference of squares. Okay. We've got a difference in the middle of our two terms. That's good. Okay. By the way, a difference of squares always has to be two terms. We've got a minus in the middle. That's good. That means we've at least got the difference part. Then if you take the square root of 4n squared, that's going to give me just 2n. And if I take the square root of 9, that's going to give me 3. So we've got two perfect squares there. We could rewrite this as 4 out in front. Don't forget about that. But 4 out in front with 2n squared minus 3 squared. So when we can do that, that's our indicator that, hey, you've got a trick. So don't forget, your GCF still stays. We're going to rewrite our 4 out front. And then we've just got 2n plus 3 times 2n minus 3. It's that simple when you have a difference of squares, okay? One last one. Let's look at this third one. First thing we're going to do is check to see if we can factor out a number or a variable. And if you look at this, the numbers, we can't factor out a GCF with either of these because the only factors of 1 and 25 are 1, 25, and 5 and 5. And the only one that we can factor out of 36 is a 1. Okay, so we can't factor out a number, but what we can do is we can factor out an x because they've both got an x. So let's factor out an x. When we do that, we've got x times 36x minus 25. Okay, now we've got a difference, so we know that we've got a difference. Okay, let's check to see if we have two perfect squares. If we take the square root of 36x, don't forget that that x is in there. We are not going to get a perfect square there because we've got the square root of 36, which is 6, but the square root of x is just the square root of x. You have to have an x squared in there for it to be a perfect square. Okay, and then our square root of 25, that's going to give us a perfect square as well, But the issue is that this is still here. So that makes it to where this is not a difference of squares problem. We're actually already done right here. Okay, so be careful with that. A lot of people messed that up on the quiz. They saw something and they thought it was a difference of squares when it was not. So be very careful when you're doing that with difference of squares. First, always check for your GCF no matter what you're doing.